Okay, this is 2.4 linear, exponential, or neither. So through each of these, we're just going to be identifying what kind of function it is and how we know. So on the first one, it is a straight line, therefore it is linear. The second one, we have it going from 64 to 32 to 16 to 8 to 4, which is multiplying by half, which makes it exponential. On the second half of the page, we have y equals 4x. This is in slope-intercept form. Most people don't recognize that until you put a plus 0 on the end. So y equals 4x plus 0 is just like y equals mx plus b, which makes it linear. It's just that our y-intercept is 0, so it's y equals 4x. The next one, a function is decreasing at a constant rate. Constant rate is your hint that it is linear. So linear has a constant rate of change. The next one. So linear makes a straight line. This is not a straight line. Exponential, if it's exponential growth, it goes up from left to right. If it is exponential decay, it goes down from left to right. And it flattens out either at the start or at the end. This one, on the other hand, kind of flattens out as it goes up. This is neither. This is actually a square root function, a radical function. So it's not a J shape, it's not an L shape, it's not a straight line. It's neither. So on to the next page, a person's height as a function of a person's age. So what we did in class is we talked about age and height. So where one person in the class may have been 14 and was 5'6", and another person was 14 and 6'2", and then I am 36 and I'm 5'6", there is no connection between age and height. You could also have people that have genetic conditions that keep them from growing above a certain height, or you could have genetic conditions that make you incredibly tall, no matter your age. So there is no relationship between age and height. So this one is neither. No relationship. So the next one, if we rearrange this, we could figure out how to get this into slope-intercept form. So that's what I'm going to do. X has no exponent, X is not in the exponent, therefore more than likely it's linear. So in order to check it, we try to get this into slope-intercept form. So I'm going to bring that down. I have a negative 3x and a negative 7 on one side, and then I have a 4y on the other. Now, personally, I like to have the y on the left, so I'm going to rewrite this by swapping everything, but keeping the same values. And then I'm going to divide all parts of this by 4, and I end up with y equals negative 3/4 x minus 1.75, or 7/4. So because this is now in y equals mx plus b, that slope-intercept formatting, this is linear. So when we move on to the next one, the first thing I notice is that my x values are increasing by 2. The y values are decreasing by 18. So that means we have negative 18 is your change in y over positive 2 is your change in x. And when we do negative 18 divided by 2, we get negative 9. So it is a constant rate of change because it stays the same throughout that whole table. So it's a constant rate of change. Put ROC for rate of change. So on the next page, we have this one. So we have 62 inches has a shoe size of 6. 74 inches, shoe size 13. 70 inches, shoe size 9. And then I jump down and I look at this. And I see that somebody who is shorter has a bigger foot. Even on the next one, we've got somebody that's 53 inches and a size 4 compared to 62 inches and a size 6. It's all over the board. So this one is neither. There's no relationship between your height and your shoe size. You can be the same height as somebody with a different shoe size. So the number of cell phone users at Centerville is a function of years if the number of users is increasing by 75% each year. So each time we've done these percentages, they've been exponential. And it's because it's growing by a percent each year. It's not a set percent, it's a percent of the current amount. So this next one is your J curve. So it's exponential. And this is actually exponential growth. On to the next page. It takes time to get to work as a function of the speed at which you drive. No one is driving the exact same speed the entire way to work. So your speed may increase and then decrease and then increase again and then decrease. So this one is neither. Your speed is not constant, nor is it growing at an exponential rate. This one, there's a 2 in the exponent. Remember, for linear, there is no visible exponent. The x value in y equals mx plus b has an implied exponent of 1. So we say it's no visible exponent. Exponential has x in the exponent. This problem has a 2, therefore it's neither. So each point on the graph is exactly 1/3 of the previous point. So that means we are multiplying by 1/3, which is exponential decay. And then the last page. We have this. F of 1 is 7, f of 2 is 7. So if we were to create a table, we have the first term is 7, the second term is 7. And then it says to find the next term, we add the 2 previous terms. So this would be 3, 14, and then this one would be 4, add the 2 previous terms is 21. And the way I know that this means to add the previous terms is if I'm looking for the third term, I plug in a 3 for n. So this tells me f of 3 minus 1, which is f of 2. And then this one would be f of 3 minus 2, which is 1. And then over here, it lets us know that our first term is 7. Oops, sorry, wrong one. Our first term is 7, and our second term is 7. And that comes straight from these over here. Second term, 7, first term, 7. So if we're looking for, and 7 plus 7 is 14, so that would be your third term. If you're looking for your fourth term, you replace the ends with 4. 4 minus 1 is 3. We already just found your third term, which is 14. 4 minus 2 is 2. And your second term is 7. 14 plus 7 is 21. That's our fourth term. And you could continue on like that. Because it has those repeating 7s at the beginning means we would add 0. And then it's add 7. And then it's add 7 again. It's not constant. There's not a multiplier that works with this. So it's neither. All right, on the next one. If we rewrite this in sequence notation, we would have a sub 1 equals 1. And then you'd have a sub n equals 2/3 times a sub n minus 1. That is the recursive formula of a geometric sequence. And we said arithmetic is the same as linear, exponential is the same as geometric.